Hello friends, this question is from the subject of network theory in the topic of network theorems. Okay, so in the question, it's a common data question. Common data. So we have eventually two questions. In the question, it is given that we have a circuit which has a resistor, one inductor, one capacitor, and one dependent current source. Dependent current source. Circuit also have input voltage source. Input voltage source has a value of 30 with phase angle of 0 degree. Resistance has a value of 200 ohm. Inductor has a value of J20 ohm. Capacitor has a minus J10 ohm. Dependent source is dependent upon 30I, where I is defined as a source current. Okay. The open node is A and B. We need to calculate first RTH equivalent resistance of the network. Second, circuit element for Norton equivalent circuit. So let's have a look of the circuit. It is a circuit which contains a dependent source and an independent source. Circuit which contains the dependent sources and independent sources both. To calculate the VOC, open circuit voltage, and short circuit current to get to know the circuit elements of this. So for the open circuit voltage, I know that my output terminal is already open. So VAB is equal to VOC, which could be the voltage across the inductor, because the output terminal is open circuited, so there is no current flow across this capacitor. So there is no voltage drop across this element. So whatever the voltage present across this inductor will be directly transferred to the VA across the VAB. So it is equal to the just 30. It's a simple voltage divider into J20 upon 200 plus J20. If I may calculate it, it comes out at 2.985 with a phase angle of 84.28 volt. VOC or VAB. Now you can see the circuit. In the circuit, we have a dependent current source. If by source transformation I can convert it to a dependent voltage source, and after that I can find out the short circuit current across the terminal A and B. So let's redraw the circuit by replacing the dependent voltage current source to the dependent voltage source. So my first loop will be going to remain the same as previous. But in the dependent terminal, now my dependent current source will be replaced by a dependent voltage source with series capacitor, and my output terminal will be shorted. If I may write it down, my voltage source as the previous is 30 volt, resistance is 200 ohm, inductance is nothing but a J20 ohm, but now the dependent source has a value of 300I, where I is defined as the input current, and the J20 ohm, and A and B terminal is shorted. Okay, it is J20. If I can redraw this thing by different color so that it's visible better. So I have applied the source transformation here. We know the source transformation. If I have a current source I with a parallel resistor R, I need to transfer it to a voltage source. So simply the parallel resistor will be converted to the series resistor, and the direction of the voltage source will be in the direction of the current. The magnitude will be IR, and the direction of the current will be my direction of my positive plate, my voltage source, because my current is always flowed from positive to negative. So that's why I can convert my voltage source, my current source, into the voltage source. A simple source transformation. That's what I have did here. So now, if I may find out the input current I by the circuit, so I is nothing but a 3 of 0 degree minus, if I may name this node as A, so 30 minus VA upon 200. Now let's apply the KCL, Kirchhoff's current law, at node A, assuming the branch current is going outwards. Apply Kirchhoff's current law at node A. Kirchhoff's current law says that the sum of the incoming current is equal to the sum of the outgoing current. Some of the outgoing currents are the current across the inductor and the current across the dependent source. Incoming current is just the current coming from the resistor. So my outgoing currents are VA minus 300I upon minus J10 plus VA minus 0 upon J20. 0 because the inductor, the other terminal of the inductor is 0. And this is VA and this is 0. So now it is equal to the 30 minus VA upon 200. So now I can put the value of I here. So it is VA minus 300 times 30 minus VA upon 200 upon minus J10 plus VA minus 0 upon J20 is equal to 30. 0 minus VA upon 200. So from this equation I can calculate my VA as 28.36 with a phase angle of minus 160.97 volt. Because I have calculated the VA, I have the expression for I, so I can calculate the I also, which can calculate it as 0.287 with a phase angle of 9.24 ampere. So from the above equation you can see that we have short circuited the terminal A and B, so current flowing across this terminal is ISC, short circuit current. Short circuit current is nothing but the current flowing from node A to ground. So this short circuit current source will be equal to ISC will be, I can calculate ISC as ISC will be equal to VA minus J 300I upon J10, which comes out to be 9.53 with a phase angle of 172 minus 19 am. So I have ISC. I have a VOC as, which is also known as the VAB, as 2.985 in the phase angle of 84.28. So from the help of that I can calculate my Z as VAB upon ISC. 2.985 phase angle of 84.28 upon 9.53 17.19 is equal to the 0.313 the phase angle of 92.1. In the question we only need to calculate the magnitude. 0.313 is your answer and the correct option is A.